and resource consumption. Moreover, the use of high-pressure super-strong materials manufacturing technology can also have significant economic benefits. By improving the performance and durability of materials and products, this technology can drive innovation and growth in related industries, and create new jobs and industries. In addition, the use of high-pressure super-strong materials manufacturing technology can also have significant environmental benefits. By reducing the environmental impact of materials and products, this technology can contribute to a more sustainable and equitable future for all. To fully realize the potential applications and benefits of high-pressure super-strong materials manufacturing technology, it is important to invest in research and development, and to promote collaboration and interdisciplinary approaches. This can involve the development of new materials and processes, as well as the adoption of responsible and sustainable manufacturing practices throughout the life cycle of materials and products. Moreover, it is important to engage stakeholders and the public in decision-making processes related to the development and adoption of high-pressure super-strong materials manufacturing technology. By promoting transparency and collaboration, we can ensure that the benefits of this technology are accessible and sustainable for all. Despite its potential applications and benefits, high-pressure super-strong materials manufacturing technology also faces several challenges and limitations. These challenges include the high cost and complexity of the manufacturing process, the need for advanced equipment and expertise, and the potential risks associated with the use of high pressures and advanced materials and processes. Moreover, the adoption and integration of high-pressure super-strong materials into existing industries and applications can also present challenges, such as the need for new standards and regulations, and the need for training and education of the workforce. To address these challenges and pursue the opportunities of high-pressure super-strong materials manufacturing technology, it is important to promote collaboration and interdisciplinary approaches, and to engage stakeholders and the public in decision-making processes. This can involve the development of standards and guidelines that ensure the responsible and ethical use of high-pressure super-strong materials, and that promote equitable access and distribution of benefits and risks. Moreover, the future directions of high-pressure super-strong materials manufacturing technology can also benefit from interdisciplinary and collaborative approaches that bring together experts from a range of fields, such as materials science, engineering, and sustainability. Collaboration can foster innovation and progress, and can lead to breakthroughs in the development and adoption of high-pressure super-strong materials. Looking towards the future, the potential applications and future directions of high-pressure super-strong materials manufacturing technology are vast and exciting, and hold promise for improving our daily lives and advancing our society. For instance, the development of new materials and processes can enable the creation of novel medical devices, energy storage systems, and transportation technologies that are stronger, safer, and more sustainable than ever before. In addition, the development and adoption of high-pressure super-strong materials manufacturing technology can also have significant economic benefits, by creating new jobs and industries, and by driving innovation and growth in related fields. High-pressure super-strong materials manufacturing technology has the potential to revolutionize various industries and sectors by providing materials that are stronger, more durable, and more sustainable than conventional materials.